Let's get started. So this part says the process of transforming a compound algebraic fraction into its sum of partial fractions is called resolution into partial fractions. So basically that's what I just discussed in section A ago. So we say when we take this compound algebraic fraction into the sum of its fractions, we call it the resolution into partial fractions. And let's take the first example. It says resolve 2x plus 3 over x plus 1, x plus 4 into partial fractions. And yes, we're starting with the easiest type now, the type with the linear non-repeating denominators. So let's start from here. So now we have 2x plus 3 over x plus 1, x plus 4. Now we are going to make a little bit of an assumption here, and the first example will direct us the example we initially did. So look at this now. When we got this compound algebraic fraction, that is the step we are familiar with. We got 7x plus 19 over x plus 1, x plus 5. Now, remember that in our partial fractions case, we are doing it from year to year now. So we already have this. We want to get this and this. There's something we can easily tell. We got this place to be 3. We got this place to be 4. But if you look at our denominator from this place, so that means our 3 and 4 does not have any connection to the numerator at all. That's what I'm trying to say there. So, but if you look at the denominator, we have this place to be x plus 1. This one is x plus 1. We have this place to be x plus 5. This place is x plus 5. So it means that any partial fraction we have, all we just need to know that we are going to get two different numbers. But the first number will be over this, and the second number will be over this. So that's just this is idea that is telling us. So if we take the wisdom from here, from this particular setup into our work, we can say that our 2x plus 3 over x plus 1, x plus 4. So it's going to be a over x plus 1 plus b over x plus 4. So this is an x. So the idea is that I said that, we are going to have a number here, which is for this, another number here with this, because we don't know these two numbers yet. And that's what we are going to try to solve for, which is what we took from this particular setup. A over this plus b over that, just like this. Okay? So now that we have it, let us continue working. From the left hand side, if we try to add this our new fraction, which is going to be the same format as our answer, as our given fraction, our LCM is going to be what? X plus 1, x plus 4. If we take the entire thing and divide by 1, x plus 1, we have a, open brackets, x plus 4, and we have b, open brackets, this called this, and we have what? X plus 1. So that's equals to 2x plus 3 over x plus 1, x plus 4. Alright, so that's it. That's the step. And now, since the entire denominator are equal and alike, that are identical to each other, we can leave it aside. It's not going to help us or solve anything. We can just work with the numerators. We can say equating the numerators. Equating the numerators. I'm going to have what? 2x plus 3, 2x plus 3 equals to, on the left we have a, open bracket, x plus 4 plus b, open bracket, x plus 1. Alright, so now how do we solve this particular problem for a and b? There's an easy way for this setup, and this method only works for type 1, which is your non-repeated linear factors. This only type, that's the only way it works for. As we go into the complex type, it doesn't work, but I'm going to show you how this method breaks, and I'm also going to teach you the other standard method which we will always use. But for now, just to make the idea of the topic work easy for you, let us just see the method I am talking about, and this is how it works for. So for you to eliminate b away from this equation, because we have two unknowns, if I can eliminate b, I will solve for a, and if I can eliminate a, I will solve for b. That's the idea I want to use here. So to eliminate b, all I just need to do is to just come to the denominator of a. X plus 1 is there. So if I take x plus 1 equals to 0 and x is equals to minus 1, my x is equals to minus 1. By the time I put minus 1 into this space now, minus 1 plus 1 to be 0. B times 0 is 0. I have successfully eliminated b there, and that makes my work only in terms of a, and I can solve for the answer. That's what we are going to be doing. So we can say, oh, okay, put x is equals to minus 1. If you put x is equals to minus 1, we have 2 open bracket minus 1 plus 3 equals to a open bracket minus 1 plus 4 plus b open bracket minus 1 plus 1. So 2 times minus 1 is minus 2 plus 3, which is equals to a open bracket minus 1 plus 4 is a 3, and then we have minus 1 plus 1 is 0, and this is what? 0. So this minus 2 plus 1 plus 3 is 1. So this is telling me that 1 is equals to 3a. By the time you divide by 3, divide by 3, cut, your a is equals to 1 over 3. Now we have successfully solved for a, and it's time to solve for b as well. So the same idea I used to solve a, I'll use it to solve b. And what do? I'll say, oh, if x plus 4 is equals to 0, x will be equal to minus 4. So I will say, oh, okay, put x is equals to minus 4. And what will I have there? I will have inside this equation already. So that's going to be 2 open bracket minus 4 plus 3 equals to a open bracket minus 4 plus 4 plus b open bracket minus 4 plus 1. So 2 times minus 4 is minus 8 plus 3 equals to minus 4 plus 4 is 0. 8 times 0 is 0. Then plus b open bracket minus 4 plus 1 is minus 3. Now minus 8 plus 3 is minus 5, and minus 3b. So if you divide by minus 3, I have that b is equals to 5 over 3. So we've gotten a to be 1 over 3 and b to be 5 over 3. So what is left for me to do? Since I've gotten my a and b, I will substitute them into the mock-up partial fractions that I initially have. So once I make it put there, I have successfully solved the question. So what do I have here? I will say, oh, okay, since my 2x plus 3 over x plus 1, x plus 4, x plus 1, x plus 4 is equals to a is what? 1 over 3. So that becomes 1 over 3 over x plus 1, then plus b. B is what? 5 over 3. So that's going to be 5 over 3 over x plus 4. So now we are done. We've resolved it into partial fractions, and this is one and this is the other one. But we could also do it even one further. We could actually take this 3 down here so that it becomes 1 over 3 open bracket x plus 1 plus 5 over 3 open bracket x plus 4 as well. So we've summarized it into this neat form that we have. So that's how to resolve into partial fractions. And remember, this is a simple method which works for your type 1 only. In fact, by the time I show you where this method breaks, you won't even need to bother if it works for type 1 or which particular type it works for and stops working for. All you just need to know is identify where it stops working, so you use it elsewhere. And that's how to solve partial fractions. So just like I said, we were able to resolve these 2x plus 3, x plus 1, x plus 4 into these two partial fractions. By the time we add up these two fractions together, we will arrive at this, just like this particular first step showed us. And that's what the topic entails. I hope you understand this first method that we did. In the next video, I will show this method again, and I will also introduce the third method of solving.